Okay, so the program for this job, I had something similar before. There's a couple differences on length, and this one's we also gonna do milling, but we're gonna try to keep as much of it as possible, so it's a little bit less work. It's not that it's a lot of work anyway, but we have so this is gonna be a facing. It's gonna leave 3,000 for the finish. Our tool is gonna be a 55 finishing, depth of cut 15,000, and then your C speed is 320, 7,000 feet rate, and an M8 for coolant on. And then we have another line, which is the finishing line. The C speed is gonna be 420 and 4,000 with M8. Now there's let me see, I'm gonna find that. So there's another finish right here, which is asking me for a finish. So normally, sometimes when you do run a finish, you can actually run two finishes. You can add, let's say, put 5,000 on it. You can copy this, remove the roughing, and just leave a finish. So now you have actually two finishes. One which is going to be additional, let's say, 5,000, and the other one is going to give you, the actual 0. Starting point, so the part is 1 1/4 inches, so I'm starting 100,000 higher, so it's going to be 1.35. Since we set, we're actually going to move this here. I'm going to pin it. Get this the 3D model, and so we set our 0 at 30,000, so I'm gonna give it an extra room. So I'll put in 40,000 on the length. That's gonna be it. And then for OD turning, all this part needs is a chamfer. So instead of 1 1/4, I did 1/300, 10,000 on your finish on your X, 3,000 finish on your Z. And this is gonna be the only finish. So normally you're gonna see two lines. One is gonna be rougher, R and F, and since this is just chamfering, so it's only a finish. Rougher can be deleted, same tool, and then you see a line which is, so like I said, normally it's 1/4, 1 and 250, so I went 10,000 higher. That's why instead of the corner of 30,000, I went with 40,000. And then 150,000 deep. Now there's different ways to do it. You can turn this into a chamfer, or actually a taper. Let's say that sometimes when you throw in these corners where the tool goes up in the air, it might leave you a burr. So the way to do it is we're gonna modify this. I'm gonna do a taper. Now starting radius, so we're gonna round it up. And remember, when you put a radius, this gotta turn green, and let's say we point 0.006, enter. And since this is gonna be a 30,000 chamfer, then 1 and 250 minus 60, so it's 30,000 times 2 per side. That's gonna be 1 inch and 190. Starting point Z is gonna be we're starting from a 0, then final you're gonna do 1.25, and then final on Z we can go and throw in the question mark. We're gonna throw that 8,000 radius here. See, I forgot to press the green and it turned it into corner 0.008, so it's gonna round up that corner. It's gonna do a 45 degrees. You come, press the arrow, you press the calculate, and it's gonna turn that Z into 30,000. Okay, so this is a roughing surface. I don't usually touch it. All my surfaces are pretty much here. So now press enter, insert. We're gonna insert another line. So So this is gonna be another taper, so it doesn't just do the taper and go out. So we're gonna go 1.255. Okay, so 5,000 higher, 1.100, and it's gonna go up in the air. Okay, so this is a drilling XC. I don't have that drill anymore, so I'm gonna erase this. This is another drill. This is gonna be a chamfering drill, but I don't actually have a drill to size, so I'm gonna use a smaller drill. I'm gonna come in with the bar, and we'll do a chamfer with the bar, so I'm gonna erase that too. This is gonna be another drill. So the drill we have, it's gonna be 670, I think. Okay, or 680. Let me see what I have. So 670. If you press, so let's say 670, pattern 1, auto set, so 670. So let's say do second cut 300, third cut 300, surface speed 120, feed rate 3000. We're going from a 0 to 1850, which is about 200,000 further than I have on the drawing, because this is a taper drill, so that tip alone loses about 150,000. There's you can actually put the value into a machine on the drill. What it does usually when it enters, it slows down the feeds by half for the first cut, which I don't care for doing. But let's say if you put a 45 angle or 60 angle, it will give you the compensation. So if you tell her you need to drill 1.5 inches, it will give you that flat surface 1.5 inches plus that taper, which is a nice feature that's built in. So this we can do. Okay, before that we actually gonna add a center drill. So we're gonna press insert. Okay, it's gonna be a shape end. This is gonna be a turning key drill, 0.320. So that's automatically 0.320 C for a C drill. Same thing, pattern number 1, auto. And since we're not going that deep, so I don't care about these smaller values. Let's say 60.003,000 feed rate and 8, starting from 0, and we're going to a 300. So now we have a center for the drill, and then we have our bar, which is going to be 650. That means, what do we have here? So we have a tool of 380 now. So I had a micro bar before to do the chamfer. Okay, so we can also, looks good. So we'll go from 800 and 0 to 660. Okay, so we have a little bit different hole. So right now it's asking for 688. 688. Okay, 300. So let's go here. 820. 0. 688. Okay, we're gonna question that. So let's erase this to keep it the second line clean. 45 final corner. We don't care about that. There's a thread gonna go in there. So final corner. So let's calculate. Okay, so we have a 66,000 chamfer. Actually go even a little bit bigger. Well, it's actually a fine thread, so we'll see. Usually what you can do is later when you program the thread, you can look at the depth. So let's say if the depth of the thread will be 70,000, then I will do 80,000 chamfer, so 10,000 a little higher. So let's go 835. 688, so question mark. calculate, and okay, now we have a 72,000. Okay, and now we have the thread in. So let's see of the thread. So my thread is calling for, let me see, pitch 16. So pitch 16 is gonna be, let's see, 16 divided by 1. Oh shit, 1, sorry, divided by 16. Okay, so 62.5. Okay, so my thread pitch is correct on this one, 63.5, and it's calling for 3/4. So this is going to be a right hand side, right hand regular thread. There's another thread. Okay, so this is actually, I do double thread. So because it's aluminum, sometimes what I do is you can run extra 3 passes to open it up. And this one, it's the second one, it's actually on the other side, it's a left hand thread. So I start from 440 and then I go back to plus, actually outside minus 0.2. So that's how you do a left hand thread with the right hand threading bar. Okay, so as you press 1, we do set. So now this turns gray, and we'll do the same thing with this one. Okay, now it's gray out, so I mean it's inactive. So when you go over here, you could see we're gonna do facing, bar, T-drill, bar. This is gonna be a bar in, and we're gonna use that 6 and 7 thread. So we press on the grease, if that gray out, we go here, and we do cancel. And for the second side, I'm just gonna make the 6 and 7 inactive, and then 8 and 9 active, which is gonna do a back threading. Cancel, and now they're back at the work. So this is an easy way to, this is my way how to, let's say, redo quick program of something that I've done similar. Hopefully maybe there's something you can get out of it. Like I said, I'm not a video pro, so sorry if the video is a little shaky or you cannot see some details, but this is just to help out a little bit for some. Later I'm gonna be doing a pocket mill, so I'll bring it back if I'm gonna make another video for milling. Thank you.